Hi there, this is Jacob Nash Engineering Lessons, and this is Unit 2.1, Lesson um, 2, I'm pretty sure. I forgot actually, but sorry if it's not 2. I think that's what it is. But anyways, it's on Centroids, and in the next lesson, we'll look at how to solve the problems on Activity 2.1.1. Now, I'm doing something interesting with this. So I have one computer that's looking down at a piece of paper that is sharing a screen with this computer. So that's why it looks a little bit strange. But I actually have the PLTW notes here. So that's more helpful for this occasion. And I actually, yeah, this is lesson 3. I just realized that. But lesson 1 there was an error. If you notice, it was muted. It's because I realized my tablet can't screen record with noise. I'll try to fix that, but I'm just doing this. So you're going to actually see me writing. So, well, actually, I probably won't write for this one. So let's get started. So a centroid is the object's geometric center of a plane or solid. And if you see, let's see, is this thing frozen? There. Um, the symbol for that looks like a BMW thing. BMW symbol. That's how you draw this. And really, it's just showing you that if something was balanced on that exact point, then it would be completely balanced. Like if a certain like if you had this circle and it was like you put a pencil on it and it was like it would be balanced. Um, so that's what that means. And so there is different formulas for certain shapes, and the 3 shapes that we'll be looking at are triangle, rectangle, or semicircle. So first, it says a square, but this works for the rectangle also. So you're going to need to find the area. So first, we know for a square, area is side squared, but for a rectangle, it's base times height. That's pretty simple. So you would just multiply these 2 numbers. Now, to find the centroid coordinates. So there's certain coordinates, which it's not like coordinates like on a XY plane, like that can be the case. But if there is no plane, then it's a little bit different. It's just showing you where from the dimensions it will be. So it might be this is how you find the x, and this is how you find the y. You just do base divided by 2 to find the x, height divided by 2 to find the y. So if you had a base of 2 inches and a height of 3 inches, the base would be 1.5 inches. Or sorry, the x coordinate would be 1.5 inches, and the y coordinate would be 2 inches. So you would go 1.5 inches over, 2 inches up, draw your BMW centroid symbol, and then draw dimensions saying, okay, this is 1.5 inches, this is 2 inches. That's how you do for a square. Now let me turn it to the next page. Now this thing's delayed. Hopefully it's not like that when I'm writing. So let's put this back. Let's see how that shows up. Okay, now we have a triangle. So for the triangle, we know that to do the area, or solve for the area, you have to do base times height divided by 2, or 1/2 base height, but I like that better if you do base times height divided by 2. Now, why that is because basically a triangle is a square in half, or a rectangle in half. So that's why you're doing the same formula, but just dividing it by 2. And to find the centroid coordinates for a right triangle, now this is just for a right triangle, but you instead of dividing it by 2, you divide it by 3. So the same process works. Then you do the same thing, you draw the centroid symbol. It's a little bit dark here. Sorry about that, but it is there. I was about to scroll. I actually have to lift this up. Let's see. So semicircle. This is a little bit more complicated. To find the area of a semicircle, you need to do 2 pi r, because 2 pi r is for a circle, but then you divide it by 2. So just like for the triangle, how a triangle is half of a rectangle, a semicircle is half of a circle, so you have to do the circle formula and divide it by 2. So it's 2 pi r divided by 2. Where's some pen? So this is what I was saying. 2 pi r divided by 2. That's area. Hopefully that showed up. And then you can see to find, well, actually it's a little bit complicated for this one. Like I said, you have to do for that, if you're doing it depends on which way the semicircle is orientated. So if it's like this, like it is right there, with the flat side down, then you're going to have to do to find the x, you just use the radius, and for the y, you do 4r divided by 3 pi. But if the flat side is to the side, vertical, then you flip that around. For the x, you do 4 radius, 4 times the radius divided by 3 pi. But for the y, you would do r, so it flips around. So these two formulas are only the case. Sorry, that's kind of messy. I can't even really see where I'm drawing, but that's only the case if it's orientated like that, where the flat side is down. But if it's turned like that, they reverse. So remember that. That's very important, or you'll get it wrong. So that's what you do for the semicircle. Now you have centroid location equations. Now this might look crazy, and it kind of is at first. If you can see these equations, they're going to be used in the next video when I explain how to solve one of the problems on 2.1.1. And if you notice on the PLTW notes, you have the step-by-step example, but I'm not going to say that on this video because I want to put in my own words so it makes sense. So that's actually it for this. I told you how to find the areas of those shapes and how to find the centroid coordinates, and that will be it. So thanks for watching, and see the next video.